Today we are going to talk about the maximum or minimum of a quadratic function. To refresh your memory, a quadratic function can be written in three different forms. The first one is a standard form, which is in form of ax squared plus bx plus c. Now the advantage of using standard form is the y-intercept, which is the constant c here. The second form of a quadratic function is the vertex form, which is written as in the form of a times x minus h squared plus k. Now, the advantage of using vertex form is by looking at the equation we can easily find the coordinate of the vertex, which is going to be h and k. One thing that you have to remember is that the formula is in the form of x minus h. So what you have to do is to flip the sign of h to get the x coordinate of the vertex, and k is the y coordinate of the vertex. If a is greater than 0, then the parabola opens upward, as in the case of this graph, and this means that the vertex is going to be a minimum. And when a is negative, the parabola opens downward. This means that the vertex is a maximum. The last form of a quadratic equation is the factored form or x-intercept form. In this form, the function is the form of a times x minus r times x minus s, where r and s are the x-intercepts or the zeros of the function. One thing you have to remember that the a value here, which is the leading coefficient, is the same for the three forms. So for standard form, vertex form, and factored form, a stays the same. Now the last thing that you have to remember is if the quadratic equation is in standard form, we can change it to vertex form using completing square method or using the shortcut, which is, if you remember, the x coordinate of the vertex is minus b over 2a, and when we find the x coordinate of the vertex, we are going to substitute it back in the equation to find the y coordinate of the vertex. So you can use any of these two methods to find the vertex form of a quadratic function. Our first example is to find the vertex of a quadratic equation in standard form. To change to vertex form using completing square, first we have to make sure that the leading coefficient a is 1. In this problem, it's automatically given to be 1, so there is no need for factoring. The next step is take the b coefficient, which is b, divided by 2, which is 5 over 2, square it, add and subtract that amount. So we are going to have x squared, f of x is equal to x squared plus 5x plus 5 over 2 squared is 25 over 4, and subtract 25 over 4 plus 7. Since we added and subtracted the same amount, nothing is changed. Now take the first three terms. Using perfect square, x squared plus 5x plus 25 over 4 can be written as x plus 5 over 2 squared, and then write the rest of the terms here. Now, if you want to make sure that everything is okay, if we expand x plus 5 over 2 squared, we get x squared plus 5 over 2 squared, which is 25 over 4, plus 2 times 5 over 2, which is 5, times x, which is 5x, which is correct. And then if we simplify this one, we get x plus 5 over 2 squared minus 25 over 4 plus, multiply this by 4 divided by 4, we get 28 over 4. If we simplify again, we get x plus 5 over 2 squared minus 25 over 4 plus 8 over 4 gives us 3 over 4. So this means the vertex is, remember the formula is x minus h. So we have to flip the sign of 5 over 2, which is negative 5 over 2 and 3 over 4. The other thing is that the leading coefficient here is 1, which is plus 1. So parabola opens on upward. This means that the vertex is a minimum. The next example is a little bit more involved than the previous one. In this case, we do have the leading coefficient a, which is not equal to 1, and also it's a fraction. But the process is exactly the same. So the first thing we are going to do is we are going to factor out the coefficients, so a becomes 1. So this becomes negative 2 over 3 x squared. Now 8 divided by negative 2 over 3 is the same as 8 times negative 3 over 2. You flip the denominator. Now 8 divided by 2 is 4, so this becomes negative 12. So x squared minus 12x plus 5. Now we are going to square half of b. Half of negative 12 is negative 6, square is 36, and subtract 36. So we get negative 12x plus 36 minus 36 plus 5. This is the same as negative 2 over 3 x squared. Negative 2x plus 36 is the same as x minus 6 squared. X squared, negative 6 squared is 36, and negative 6 times 2 is negative 12 times x is negative 2x minus 36. Now I'm going to distribute negative 2 over 3 in the bracket. I get negative 2 over 3 x minus 6 squared. Now negative 2 over 3 times negative 36. Negative times negative gives us positive. 36 over 3 is 12 times 2 is 24. So plus 24 plus 5, which is equal to negative 2 over 3 x minus 6 squared plus 29. So the vertex in this case is 6. Flip the sign of negative 6 is 6 and 29. And since our a is negative 2 over 3 is negative, parabola opens downward, so the vertex is a maximum. In the next example, we have to find the vertex, the coordinate of the vertex of function y equal 4x squared minus 12x plus 3 by partial factoring. To find the vertex using partial factoring, first we have to understand the following fact. Consider a function y equal 4x squared minus 12x. Let's assume that the coordinate of the vertex, the coordinate of the vertex is v sub x, and these are the x-intercepts. Now when we add number 3 here, what am I really doing is I'm shifting this quadratic 3 units upward. But one thing that you have to remember is that the x-coordinate of the vertex is not changing. although this one goes up, but the vertex moves along the axis of symmetry. So this means that if I find the x-coordinate of this quadratic, it is going to be exactly the same as x-coordinate of this quadratic. Now the good news is that to find the x-coordinate of this simple quadratic is much easier than the original quadratic. So I'm going to say y is equal to 4x squared minus 12x is equal to 0 to find the x-intercepts. I'm going to factor out x, 4x, so I get x minus 3 is equal to 0. So the x-intercepts are x equal to 0 and x minus 3 equal to 0, so x is equal to 3. From these 2 points, to find the x-coordinate of the vertex, I'm going to average the two x-intercepts, so 3 plus 0 divided by 2, which is 3 over 2. So this is the x-coordinate of the vertex for this, and x-coordinate of the vertex for the original equation. To find the y-coordinate of the vertex, I'm going to substitute v sub x in this equation. So I'm going to get v sub y is 4 times 3 over 2 squared minus 12 times 3 over 2 plus 3. 3 over 2 squared is 9 over 4 times 4 is 9. 12 divided by 2 is 6 times 3 is 18 plus 3. 9 plus 3 is 12 minus 6 minus 8 is minus 6. So the vertex is going to be at 3 over 2 and negative 6. Since the leading coefficient a is plus 4 and is positive, this means the quadratic opens upward, so the vertex represents a minimum point. Our next example is a word problem which states that Rachel and Ken, they have a knitting scarves to sell at the craft show. The regular price is $10 per scarf, and the cost for making one scarf is $6. So this means that the profit they make out of one scarf is 10 minus 6 is $4. And they sell 40 scarves at regular price, $10 per scarf. Now they decide to increase the price. They know that for every 50 cents that they increase, there is going to be 4 fewer scarves which is sold. The question is that what selling price will maximize their profit and what will the profit be? To solve this problem, what we are going to do is we are going to make a table of values to see if we can come up with a general formula for the profit. So let's say our table of value is in terms of x and p, which I'm going to explain what exactly x is. Let's say x represents the number of times we are increasing the price by 50 cents. For instance, if x is 0, then it means nothing is increased. If x is 1, then the price is increased by 50 cents. Since the profit is $4, then it means that if x is 1, then the profit is $4.50. If x is 2, the profit is 4 plus 2 times 50 cents, which is $1, so 4 plus 1 is 5, and so forth. So let's write to complete the table of values. When x is 0, the profit is, we know that there are 40 scarves we sell, and $4 profit per scarf, so 40 times 4. When x is 1, this means that I'm going to sell 4 less scarf, so it's going to be 40 minus 4, and the profit per scarf now is 4 plus 50 cents. If X is 2, then I'm going to sell 2 times 4 less than 40, and the profit is going to increase by 50 cents times 2. If X is 3, then again the same pattern, 3 times 4, 40 minus 3 times 4, and the profit is 4 plus 0.5 times 3, and so forth. Let's say X is X. We don't know how many times we have increased the price, so the number that I sell is 40 minus 4X, and the profit is going to be 4 plus 0.5X. This means that my profit equation in terms of X is 40 minus 4X times 4 plus 0.5X. Now if we expand this to binomials, 40 times 40 is 160, 40 times 0.5 is 20, so plus 20x, minus 4x times 4 is minus 16x, minus 4x times 0.5 is minus 2x squared. Rearranging terms, we are going to have minus 2x squared. 20x minus 16 is plus 4x plus 160. Just by looking at this profit equation, you can see that the leading coefficient is negative 2, so the parabola opens downward. This represents the vertex is a maximum, as what the question required us to find, maximize. Now, to find the coordinate of the vertex, we can either use partial factoring, completing square, or the shortcut. Probably the most easiest way to do it is using shortcut. Now to find the x coordinate, I'm going to say v sub x is equal to minus b, which is minus 4 over 2a, which is 2 times negative 2, which is going to give me 1. This means that if they increase the price once only, they are going to get the maximum profit. Now, from here I can find that v sub y is 40 minus 4 times 1, 4 plus 0.5 times 1, 40 minus 4 is going to give me 36 times 4.5, which is going to be 162. So this means the coordinate of the vertex is 1 and 162. So this means that if they change the price, instead of $10 to 10 plus 0.5, which is 10.50, they are going to have the maximum profit, which is $162. In our last example, Jamie throws a ball that will move through the air in a parabolic path due to gravity. The height h is given by the formula h of t is negative 4.9 t squared plus 40t plus 1.5. You're supposed to find the zeros or the x-intercepts and interpret their meaning. To find the zeros, we are going to use the quadratic formula. And remember that x-intercept is when h, or the height, is 0. So we are going to say negative 4.9 t squared plus 40t plus 1.5 is equal to 0. Then t1 and 2, the x-intercepts are negative b, negative 40, plus or minus square root of b squared. 40 squared is 1600 minus 4ac. So it's minus 4 times 1.5 times negative 4.9 divided by 2a, which is 2 times negative 4.9. If you use your calculator and simplify the square root, you get about 40.37 divided by negative 9.8. There are two roots if we take the positive and negative. If you take the addition, we get negative 0.038, and if we take the negative, we get 8.2. Now, what are the meaning of these zeros? These zeros represent when the ball hits the ground. So after Jamie throws the ball, it takes 8.2 seconds for the ball to reach the ground. Now the second part of the question asks to find the time needed for the ball to reach its maximum height. This means you have to find the t-coordinates of the vertex. By definition, VT, vertex, but the t-coordinate is the average of the two x-intercepts. So 8.2 minus 0.038 divided by 2. This gives us 4.08 seconds. So it takes 4.08 seconds for the ball to reach its maximum. And what is the maximum height of the ball? We are going to find the value of function at 4.08. So h of 4.08 is negative 4.9 times 4.08 squared plus 40 times 4.08 plus 1.5. If you use a calculator and evaluate this expression, we get 83.13 meters. So it takes 4.08 seconds to reach 83.13 meters, which is the maximum height of the ball.